In this video, I have a dialogue with the objectivist philosopher Ron Pisaturo about my broad physical categories. Ron asks me questions in this video about a number of important topics. Number one, the four conditioning connections. Number two, my concepts of relationship and conditioning connection as distinct from actions and causal connections. Number three, how to conceptualize change. And number four, we talk extensively about my controversial conception of force as a kind of relationship, as opposed to a kind of action, which is the way it's usually thought of. Ron challenges me on a number of different points, so this conversation is going to be a great opportunity for you to chew on these very abstract concepts and to get a more concrete sense of their meaning, application, and implications. So I hope you'll enjoy this conversation between me and Ron Pisaturo.
Yeah.
Ron has watched parts of my broad physical categories video, specifically parts that relate to my concept of a conditioning connection and my concept of a relationship as opposed to an action. And this is two controversial ideas because in my view, we need certain concepts to capture the ways that entities play a role in one another's identities, even when they are not changing. And so this is where these static connections, conditioning connections come in. And Ron has some questions about that. So let's start there.
Yeah. So I'm very sympathetic to some of the distinctions that you made, or one important one. So to say it in an example, because you can describe it conceptually better than I can at this point. But you took as one example, let's say, two different properties of right triangle, right? That its or any kind of triangle. Its angles are, it has a right triangle and it's got other angles that add up to, let's say, something, and then it also has sides that follow certain rules that are, concurrent with the angles. Those things go together. So if you know the angles, you can infer the sides, and if you know the sides, you can infer the angles. Let's say, and neither the angles nor the sides are prior to each other, right? They're both there at the same time, and if we really think about it a little more, the relationship between the angles and the sides is not the same as a causal connection between, my lifting this object and dropping it. It's more a concurrence of attributes, things that go together, right? And I think it is a good idea to distinguish that kind of relationship from what we generally think of as a causal relationship, where one entity acts on another, second entity reacts, to that, and that interaction is dependent on the nature of each of the entities, right? Now, I'm maybe not saying it as well as you would say.
Everything's 100% as far as I'm concerned so far. Slightly different words, but really it's 100% agreement, actually.
Okay, yeah, and I think it is a good idea to distinguish those kinds of things. And I remember thinking as I was watching you that this example of the triangles is also similar to the concept with the idea of a material cause, right? Because the material exists concurrently with what the thing can do, right? So if I say this object, because it's made of plastic, is going to, not be magnetic and have some other features. I can maybe crush it if I, and it being plastic does not have this kind of temporal relation with what the entity will do. It's an aspect of what the entity is.
Yep.
It's of a certain material, and it's also of a certain shape, and that's also a different kind of relationship between, let's say, the shape and the material. Different. That's a different kind of relationship than, again, my lifting the object and letting it go and having the earth pull it down. So you sort of did a little expression change there when I raised the idea of a material cause.
Yeah.
But so from my perspective, what a material cause is closer to what you're calling this kind of, I forgot what you called it.
Conditioning connection or relationship.
Connection.
Yeah.
Yeah, I think of it more, the terms that jumped out to me that I might use for this kind of thing would be a concurrence of attributes, concurrent attributes. They both exist in the entity concurrently. And it's not that one causes the other, that it's just that they're both there, and they're in certain ways, they're different perspectives on the same thing, right? So
yeah, they are different
the
perspectives.
triangle is what it is. The triangle is
Yeah.
the whole thing. And one perspective on the triangle is that it's got these angles, and another perspective is that it's got these sides, and they're different attributes of the thing, and they exist together, right? As different aspects of what it means to be that thing.
Yeah.
And in the same way, if I look at an object and I say, okay, as a whole, it's a certain object, and it's also, I can look at it under a microscope, and it's going to look differently. It's going to have different features are going to jump out at me, but they're just the same features from a different perspective, ultimately, right? It's made of what it's made of. If I look at it at a macro level, it's one way. If I look at it at a microscopic level, I see other things, but they're all there at the same time.
Yeah.
Right. So it's not like I would say the microscopic attributes cause it to have these macroscopic features. As if I'm understanding your ideas right, that would be a different sense of causality than what you're trying to describe more narrowly as causality, which I would take more like the efficient cause, when one object actually interacts with another. That's a different kind of thing, and it's not just that when we call one material and we call one efficient. They are different in kind in this other way that we're talking about. So that's how I understood your, and you're making faces as if you're thinking, and maybe you did not think of these implications or mean it to me.
No.
But I'm thinking.
Yeah, I'm making these faces because I'm trying to decide where to start on all of this, actually, because I actually reconceptualize the Aristotle's four causes as well, and I'm not exactly sure. I'll just start with the material causation. I would I would imagine that that Aristotle would refer to this. Now I'm talking about Aristotle right now, not me. But I regard Aristotle to be right in his own context of knowledge on this issue. He would call this formal cause, I think, because the particular arrangement of the parts of the triangle they sort of mutually determine one another. Like the triangle is the way that it is in part because of the form. So it wouldn't be material from Aristotle's perspective. It would be.
Yeah, I agree. Yeah, I was just thinking, my mind just jumped to material cause, not to use the triangle as an example. I agree with you.
Yeah.
As I understood your idea, it would make me put material cause and formal cause under this category of what
Yeah,
you're calling,
I
you know,
see. Yeah,
whereas the efficient cause would be more the other category.
right. Yeah. So I reconceptualize the four causes also. Although first I'll just
Well,
say
I figured,
yeah,
yeah, I figured you would, based on what you. That's why I mean, I saw that this concept that you're introducing, or this idea, would have implications on, you know, Aristotle's four causes, and I
yeah.
started to say I would put those two under this new idea of yours, and I would put the efficient cause and the other. I'm not sure what I would where I would put the final cause in your conception.
Final
Like,
cause I take off the table entirely.
really?
So just because I don't want to
Yeah.
deal with it, basically. Um,
No, but I
not that
understand
I
when
think
it does not
there's
fit in
something.
one way or the other. Yeah,
What's that?
that it does not fit in to this distinction that you're making.
Yeah, these are the
One
broad
concept.
physical categories, and so
Yeah.
like I think I haven't thought about this that much, but I would say final cause is a biological concept. It only validly applies within biology, and so I'm just not thinking about that yet, or maybe
Yeah.
ever. Um so but I end up with four causes. Actually, I add another one, but it's something that I call it passive cause. But and we can get to that if we need to understand this broader thing. So let's see. Here's the way I think of it. You have different entities. Those entities are in relationships with one another. And what that means is that they are separate entities, but they are still but they're separate entities in one sense, but then in other senses they are connected so as to condition one another's identity. And that connection is a relationship, and a relationship is seen as a static, unchanging state of affairs where the identity of one entity is, in some sense, in some manner, dependent on the identity of another. So the example I give in the video is, if you have a bunch of sticks interwoven to make a wicker fence, the strength of each stick, you can think of each stick as a separate entity. It truly is a separate entity. And I actually have a particular standard on which you can consider something to be a separate entity or part of a whole, or both. And in the case of the stick, it's both. So it's yeah. So it's in the case of the stick, it's both. The
Well, yeah,
strength,
that would, yeah, good. That would
yeah,
be like anything, like the parts of a machine, right? Parts
yes,
of a car. Yeah.
yeah. And that's its own thing. That's its own thing. But and it's all, yeah, that's its own thing. So we're talking about relationships. The strength of each stick, considered on its own, is dependent on the properties of the other sticks that it's in contact with. And I take strength to be a static property. Now, that static property pertains to the way it will change under action. But before that action occurs, the property is truly a property of the stick. And as a result, the identity of the stick is dependent on the static, unchanging identity of the other sticks it's in a relationship with. And this and so we want to say that the sticks are in relationships with one another, not that they're acting on one another. That relationship pertains to the way they might act on one another if I start pushing on the fence and start deforming it, maybe. But it's still it's part of the sticks. It's part of the fence's identity and part of the identity of each individual stick before any of that happens. So that's relationship. Then relationships in general lead to conditioning connections, and conditioning connections are just a catch-all phrase for any time one characteristic is dependent, whenever one characteristic plays a role in the identity of another characteristic. So the relationship gives rise to a conditioning connection between the properties of the stick. So the strength of one stick will condition the strength of the other stick. So it's just another perspective on the same issue of relationship. Then I characterize actions as changes in relationships. And so change and action can be conceptualized this way, basically, is just through lots of iteration of trying to form all of my concepts in a way that allowed me to capture all of the differences and similarities between all of the existents while not committing package deals or false dichotomies. I used that thought process and came to this conceptualization. And I'm not exactly sure how to argue for my conceptualization other than to simply say that's what I did. And what the other thing I could say is that if you were to identify some way that my conceptual framework commits package deals or false dichotomies or violates other rules of conceptualization, then that would be, then I need to change my framework. That's how I would think of it. So okay, and then finally to talk, and then the four causes fit into all of this, and here's how. I talk about, so I have four causes: formal cause, material cause, efficient cause, and passive cause. Passive cause is the way the entity being acted on influences the nature of the action. So, for example, my example I always give is if you swing a sword at a knight and the sword bounces off of his armor, the armor is being acted upon, but the nature of the action was in part conditioned by the nature of the armor. If the armor was leather, maybe it wouldn't bounce off; it would penetrate instead. So that's a fourth cause. Now, not only, so I add that, and Aristotle talks about what he calls passions. I didn't read too much about that, though, I have to admit. So this is not really new. I just kind of include it under the four causes. It's not really new to me. I just conceptualize it differently, I think. But I conceptualize it very differently. And part of that is that I actually have four conditions and four causes. So we have 8 categories here. And let's see. To survey these briefly, to talk about let's just talk about formal conditioning. Formal conditioning talks about the way the constituent entities and their relationships with one another condition the properties of the entity as a whole. So, for example, those sticks I was talking about earlier, part of what conditions their strength is the relationships between the cellulose molecules. I don't know how that works, but the sticks are made of cellulose, I think, if high school biology serves. And they're in a relationship with one another. And of course, the fact that they are cellulose, that's the material condition for its strength. So we have these different conditioning factors which influence the properties of the entity in a static, unchanging way. In fact, I need to stop using the word influence because influence tends to connote a changing kind of thing. I need to say it plays a role in the, I have to use my own terminology. It plays the form plays a role in the identity, it plays a role in the properties of the entity. Then we got so those are the four conditions. I didn't go in detail about all of them, but that's a start. I didn't want to take too much time doing this. I just want to give you a sense of what the difference between the four conditions and the four causes are. Here's my sense of the four here's my concept of the four causes. Let's think about formal cause. Formal cause is a little different than formal conditioning. It's really similar, but it's specifically how is it that the relationships between an entity's constituents condition its actions. So one example of this is one way that formal cause manifests is in capacity. Capacity is a property of being able to act in a certain way. So, um, the formal cause. One example of formal cause would be the alloying of steel. If you alloy, or not alloying, carbonizing iron so it turns into steel. You cook the iron, you cook your iron sword. The iron is now infused with carbon. Now the sword has greater ability to penetrate leather armor, like from the earlier example. So it affects its capacities. Then slightly differently, or very much differently, is efficient causation, which I conceptualize as specifically how an entity is affected by outside entities acting on it. So in this case, the leather being perforated by the sword. So that would be an efficient cause. So that is a quick rundown of everything, and I think it addresses what you've said. So you can see everything gets changed a little bit to accommodate this need to capture static connections between facts. And dynamic connections between facts are simply conceptualized as alterations of these static connections. And what I've found is that everything fits quite nicely. All of these sort of questions about, like, is the Pythagorean theorem really is it really a causal connection? Like, all of these kind of unclarities I have found go away. But I only came up with this like 6 months ago, so it would not surprise me if further reconceptualization is needed.
So I'm sympathetic with much of what you said. I don't know enough science to know where. I'd have to think about how this enhances cognition, right? And to see whether to make sure it does not diminish cognition in some way. But it seems plausible and reasonable, especially that distinction between the relationship among attributes of an entity versus efficient causes. The question I have is a little more narrow when it pertains to your, as I understand it, characterizing forces as not necessarily causes.
Yeah.
So that's the so. Let me ask a question, and I don't mean this to be rhetorical. I'd like to understand. Do you think? Well, we know the statement about causality, that entities act in accordance with their nature. So would you say that entities exert and resist forces in accordance with their nature?
Yeah, absolutely. Now, real quick though, by forces you mean physical forces. You don't, now in your book you use the word force in a more generalized way. You mean like a causal process? Is that what you mean by force?
Let's just take things like gravitation or electrical.
So let's talk about physical forces, just literal, like actions which cause acceleration.
Yeah.
Okay. Yeah. So yeah, I would say that forces. What was exactly the nature of your question? I agreed with whatever it is you just said.
We know that entities act in accordance with their nature.
Mm-hmm.
Would you say also that they exert and resist forces in accordance with their nature?
Yes.
And so this object resists the gravity of the Earth in accordance with the nature of this object.
I
Right.
wouldn't characterize it as a resistance. I characterize it in the following way, basically. I would say the Earth comes into a relationship with the box, and that coming into the relationship is the emergence of a force. That is an action. The existence of the force itself, though, is a relationship. So the Earth and the box are now in a relationship with one another. And what this does is this relationship changes one of the box's properties. It changes the property of net force. The net force of the box is now different as a result of this relationship it's in. Then, as an aspect of passive conditioning, the box has a certain mass which conditions the resulting acceleration. So we have a efficient condition, which is the Earth's force. We have a passive condition, which is the box's mass. Then we have a resulting action, which is the box's acceleration. And it acted in accordance with its identity, and its identity was conditioned by its own properties and also the properties of the Earth.
Well, yeah. So here's now a layman's argument. You know a lot more physics than I do, of course. So, but here's an argument that because forces also act. I mean, entities also exert forces, and let's say react to forces in accordance with their nature. That's very similar right away to action, right? It's the same principle. It's and that doesn't that argue for force to be subsumed under the concept of action, because again it's a basic principle of reality that every entity has characteristic forces that it exerts and characteristic ways that it reacts to other entities. And force is so much connected to the concept of motion. Doesn't it, just from those things alone, argue for force being considered a kind of action?
Force is a kind of action, but I specifically frame it as the emergence and dissolution of forces are actions, and then the force itself is a relationship, is the way I conceptualize it. So you can say that the force is an action, but in order to capture the specific temporal nature of the process, I say that force is a relationship, and then the emergence of that force is an action.
So okay, let me give more arguments.
Yeah.
That when we have an object, even though we might not see it moving, let's say, the fact that it is exerting a force and receiving forces is an indication that there is movement and more obvious action going on. So, for instance, for me, I'm going to use this dictionary that was. I think I am acting to keep this dictionary from falling. So, to the naked eye, at least, it looks like there's no motion. And if I understand you correctly, you might say then, therefore, there's no action. but I can feel my muscles working to keep this book up.
Yeah.
And if we were to look more closely, even though our naked eye immediately does not see action, if you looked at my muscles, some of them would be firing and resting, and others, there's action going on. There's, you know, uh, making and using of energy going on in my body. There's all kinds of little actions. And now that's because I'm a person and I'm a living thing. But let's suppose, I was thinking of some of these examples. If I shine a light on this object and it looks lighter, so it changed by your thinking, by your categorizing. So it changed when it got lighter. But I would argue that so long as I continue to shine the light, I'm still acting on the book, even though
Yeah.
with the naked eye there's no change going on.
Yeah.
But by understanding that exerting of forces or interactions between entities really are actions, it leads us to think, well, maybe there's some kind of particles that this light is shooting at that thing to make it stay light. Because if I move the light away, it gets dark.
Yeah.
And it's not just that it changed for that moment. As I shine the light, there is change going on, even though it's the same light. I mean, the same brightness. I don't see it. But by conceptualizing force or any certain kinds of relations as actions, it can lead me to think, well, maybe there's something going on between these two things. And I know enough to know that people talk about photons, and it's not the same photons that keep hitting it. It's different photons. So there is a kind of change going on.
Yeah.
You know?
Yes.
And so as another example, this lower object is holding up this other object. So there is an equilibrium, right, between the Earth's pull to pull this object, this white object down, versus this other object keeping it stable. And so but what I would argue is the Earth is continuing to exert the same force on this over this white object as if I move this away. There's a continuity, there's a constancy, which is and this object in terms of gravity is different from the relation. Let's say now, if I'm shining a light from down here, should have had a light, and I'm shining it up here. This intermediate object is blocking the light, so the light is not affecting the white object, but the gravity is still affecting the white object. So even though it's not moving, and because of the gravity, and it's not being illuminated because of the light, there's a difference between those two things. In one case, the Earth is continuing to use its gravity, but another object is counteracting that by acting on this object. Whereas with the light, this intermediate flat object is not acting on the white object to block the light. It's acting on the light or the light rays to block the light rays. So its relation, this intermediate object has a different relation in terms of the light versus gravity. In one case, it's offsetting that the force that the Earth continues to use, and the other case is actually blocking the effect of the light. And what I'm arguing for is that grasping all these things is clearer if we understand these relations as actual actions.
Yes.
The light is acting on this thing, even though there's no change. The Earth continues to act on this white object, even though the object is not moving in this case. So that's an argument to say that force is a kind of action, and it helps us conceptualize because we can make this distinction. We can say the Earth always acts on these other objects gravitationally. There's that constancy that we can grasp because we think of gravitational force as a kind of action, as a constancy of action.
Mm-hmm.
Whereas the other kind of action, the shining the light, it's an action, but the light is not getting through anymore. So that action is not reaching this other entity.
Mm-hmm.
So that would be my layman's argument for saying that it is helpful to construe force as a kind of action. And again, realizing that the gravity is acting all the time, you can make one think, well, maybe there are particles of gravity as well that are bouncing from one to the other, or waves that are going on. And so it's like a green light to conceptualization by realizing or construing this relation between the Earth and the object as a kind of action.
Yeah. Okay, so let's see. This is a good objection. I think I've already covered it though, and here's how I cover it. I don't think I cover it explicitly. No, I think I do cover it in the video. Some relationships, once they're looked at, and let me know if this covers everything you've brought up, because you brought up a lot of different things. I think it covers everything, but let me know if it doesn't cover everything you just brought up. So some relationships which appear to be static, and in some sense truly are static, because the part that appears to us is truly static. Some static relationships are in fact constant processes of action. So, and in my view, part of what we need in broad physical categories is a vocabulary which allows us to capture the parts of phenomena which are currently part of our context of knowledge. We want to be able to say, this in an early context of knowledge, here's the relationship. So for example, here's an example. When they understood that atoms were joined together to form molecules, and those molecules were the formal and material causes of different chemical substances, those relationships would have been seen as static relationships. But quantum mechanics gives us when we actually look into, or I shouldn't say quantum mechanics, but our understanding of quantum phenomena, because quantum mechanics is a flawed theory of quantum phenomena. But our understanding of quantum phenomena shows us that these bonds are the result of the electrons being shared between the two atoms. And we don't understand the details of that exactly. I don't yet, but it seems to me like that's probably some kind of constant process of action. There's something the electron is doing to both atoms constantly, like maybe bouncing back and forth. Yeah. It's not that simple, but like it's some kind of constant process of action. And we need, but here's the thing, at the level of chemical bonds, that's a static, unchanging relationship. But then when you look deeper into the nature of that relationship, we see that it's a constant process of action.
Right.
A simpler example, I should have,
yeah. That's kind of what I'm getting at.
Yeah. So my only point here would be that we want to be able to look at it from different, even once we get that quantum perspective, we want to be able to shuttle back to the more primitive perspective and say, that constant process of electron action between the two atoms is the relationship. The relationship is there and static and unchanging so long as the as long as the electron is doing that thing, doing that action. Um, and that action is then understood as a truly constantly changing. And then if we want to understand that action, we would have to understand the changing relationships between the electrons and the two atoms, whatever that dynamic process is. And so I believe this does allow us, my conceptualization does allow us to capture all of the considerations you're concerned with here. But let me know if I did actually capture everything.
Well, I'm raising this all by way of saying, I'm not trying to like catch you in a mistake, but it just so
You totally should catch me in a mistake, though, because I've been working on this for really, really long. And so I'm probably not going to catch me in a mistake anymore because I've been thinking about it this way so long. So please do try to outwit me here.
Okay. Well, it's that when I said last week, entities act in accordance with their nature. The law of causality, applies, and I thought you said something to the effect that, well, the law of causality is not ubiquitous because sometimes an entity is not moving or not acting, and really action applies to when it's in motion. And the motivation for my questioning was the first question I asked you in an email was, aren't things always acting? And even the exertional forces. And I think this example you gave, that even on the quantum level, that even when something seems static, it is acting. The entities are still acting on each other. And I understand that we want to have a concept of static at a certain conceptual level, and we consider certain things as unmoving, but I think it helps to consider action, the concept broadly, especially as it's used in the law of causality, to encompass these instances in which there are forces around. And even if you don't see anything moving at the macro level, you still construe the forces as actions. Now, one thing, it's a clue to the kind of example that you gave, that if you look deeply enough, you will find motion, probably. But just more generally, it's good to construe the concept of action broadly enough that it encompasses all of these properties of the thing, including the forces that it exerts. This is all by way of saying I think it's helpful to think of force as a kind of action.
Yeah, right. I would simply say that to capture the kinds of, in order to capture like static relationships, we need the concept of you're only asking about force. So yeah, let me try this. You're really only talking about force, and by that, physical force, as opposed to political force, specifically physical forces. So
Yeah.
Yeah, it is quite, I'll admit, it is quite strange to conceptualize force as a relationship. That is very unusual. But here's one argument. Here's another argument I could give for why we could do this is we need a concept for change. No, that's not what I'm trying to say. We need a concept for the way entities influence one another in these static ways. Then we need a concept for the way that they change, like these relationships change, and I would just put it this way. If you look at Newton's second law, F equals ma. Well, first of
Mhm.
all, it's F net equals ma. F net. So this is a
Right.
yeah. So this is a statement. This is really a statement about um the causal. This is a statement about the not the entity acting, not the entity producing the force, but it's a statement about the entity sustaining a set of forces. The entity, there's gravity. We each have our different entities as our example. So we got this, we got this body, and the gravity is pulling down, the hand force is pushing up, and these two forces come out to zero. And I see no other way to conceptualize that consistently other than to say that this yo-yo has a property called net force, and that property dictates its future actions, or its current actions, I should say, namely its acceleration. um, and so and the forces of gravity and of the hand, whatever the underlying physical nature of those forces are, may constitute some kind of constant process of action, but the force itself is unchanging. And to address something you were saying earlier, I'm exerting effort to keep the yo-yo up. Um, and the way, and it seems like, and it very much seems like effort, physical effort, is a constant process of action. It's not some kind of static relationship between the parts of the body. And I would say the muscles have to contract in a certain way. So the muscles are maintaining a particular static relationship with respect to one another. Let's say I'm actually standing completely still. But in order for the muscles to do that, in order for the little fiber, I don't know how muscles work, but I think it's that the little fibers are like pulled together towards, the little fibers pull towards one another, I think. In order to maintain that particular distance, the muscles need to continue to burn um, ATP, I think, in
Right.
order to maintain that relationship. So a
Right.
constant process of chemical action is necessary. And then up here, we have to go through a constant process of psychological action to maintain that process of chemical action within the muscles. And so the constant process of action that you're perceiving is that in your body. It's not, but then in terms of the actual physical, strictly physical relationship between the yo-yo and the hand, that's a just a relationship.
Yeah. So what I would say with that is that when we want to understand entities, and now I know that thing is a yo-yo,
Uh-huh.
that I to understand it, I want to know not only how it is in this particular relationship with your hand, right? I want to know the weight of that yo-yo, how it
Mm-hmm.
will act in other ways. And so I want to understand the characteristic way in which that entity exerts forces,
Mm-hmm.
how much gravitational pull it exerts on other things, like
Mm-hmm.
its weight, which we then know comes from its mass, right?
Mm-hmm.
So, and it's useful. It's very, very useful to grasp that whether that yo-yo was in motion or going very fast, going up and down, or static, it's got a constant weight. And
Mm-hmm.
that tells me how it will act in many other situations. And so I want to know its characteristic way of exerting a force. And I think
Mm.
conceptually, it's simple to grasp that by saying, well, its exertion of a force is like its other actions. It's another one of the things, one of its characteristic ways of acting. It exerts a pull on these other things.
I think I agree with everything you just said and think it fits into my framework, because I simply would say that to exert a force is to create a force relationship, and that exertion is an action. That creation of the force relationship is an action. So we can
But
say,
that force,
yeah,
yeah. But does
the,
that force relationship exist all the time? I mean, does
no,
that
it,
characteristic of the yo-yo of exerting that force, isn't that always true?
the property which causes the yo-yo to exert certain forces is there before it exerts the force.
Yeah, okay, but isn't it always exerting that force?
It depends on what force we're talking about. Like maybe
Right,
gravity, it's pulling
gravitation.
nearby
Yeah,
objects towards it.
yeah.
Um, uh, let's see. So the way I would conceptualize it is this, and I'm going to do this based only on a Newtonian understanding of gravity. If you
Yeah,
try to
that's what.
get, yeah, if you try to get deeper into understanding the underlying cause of gravity, this gets more complicated.
Mhm.
But I think one feature that the broad physical categories needs to have is they need to be able to be applicable at any level of analysis. We can't have one of these Democritus situations where, or I don't know if that's quite the right way to put it, but like it seems like a Democritus type error where you say like, oh well, really, if you zoom in enough, it'll always be some kind of process of action, and so the static relationships aren't really real. Like, no, I don't want that. We need to be able to describe whatever our knowledge is at any stage without contradicting anything. Okay, yeah. So explaining this from just a Newtonian context, we won't take the yo-yo. We'll just take the Earth and the Sun. So the Sun is in a particular relationship with the Earth. Okay. And the reason we know this is because the Earth has a certain net force on it at some particular instant. That net force depends in part on the distance between the Earth and Sun.
Mhm.
Okay. In the next moment, that distance will be different. So the Earth, and as a result, the force will be different. And so the nature of the relationship changed. So the motion of the Earth around the Sun and the constantly changing gravitational pull on the Earth, that is a process of action. And process, I don't think I use this word in the video, but a process is a set of actions, each action conditioning the next. Uh, so that's what a process. That's also a word, a broad physical category. So this is a process. So it consists of a set of actions. Each of those actions is a changing relationship.
Okay. Now, of course, I'm not claiming that you don't account for every kind of phenomenon. You certainly do. The question has to do. My
Mm,
question have to do with what is the best way conceptually to hold all these to to hold these concepts, or which concepts to form such that our corpus of knowledge will be best organized.
yes.
That's really the question.
Yes.
And so here's how I would say, following up on what you said, why I think it's useful to consider that the law of causality applies all the time, whether things are in motion or not, because Earth and the Sun have these forces on them, or exert these forces with each other. If we get a third body in, it doesn't change the forces between these two. It just adds another constellation of forces, and so it's useful to my mind to think. It's useful to think of to think of some constancy in the situation, that the Earth is always acting in a characteristic way, of exerting a certain amount of force that's based on its mass, and of course the distance from other things. But it's putting out those forces based on what it is, And the great thing about the law of causality is it says that a thing has its nature and it acts in accordance with that. And I think it's helpful to fold in or include in all the instances that the law of causality is going to apply to include the cases in which we don't see a change. And even though we don't see things changing, we don't see the thing moving, we know that there's still a constancy to the way the earth is acting.
Yes. Yes.
The way this thing. And I think that is the value of the law of causality. It identifies a constancy amid change. And now getting back to my book, so much of knowledge, if possibly all of knowledge, entails finding something that are constant amid change, some way of conceptualizing, so that I know I can make a statement that is true, not just ephemerally, but something that was true, is true, and will remain true.
Yeah.
That's the whole purpose of our forming our concepts. That's how we can project from the past and present to the future, right? So we're looking, and I think the law of causality gives us this constancy, but it gives us this constancy also in the realm of forces, if we construe forces as actions,
Mhm.
and that we can find constancy to the way entities exert forces and fold that into the law of causality.
Yeah. There's two things that come up to me here, which is, well, first, I completely agree with the aspects of the book you've mentioned so far. The idea, like, it's a really good point. You can't describe change unless you describe it in terms of some nature of the change, and the nature has to persist throughout the duration of the change. Otherwise, all you could say is like, well, it's changing. Well, but even if you say that, you're saying something about that transition, that like you are identifying a constancy. You're identifying a kind of constancy. The constancy is that its nature is changing. So anyway,
right.
Yeah.
And then,
so even that's an example.
And the scientists can make it more constant by finding a mathematical relation.
Right. Yeah. I suspect that there are non-mathematical laws as well that this would apply to. So the other thing that something it strikes me that you may have found a deficiency in the framework is that I have a law of causality. Soon I will be publishing what I call broad physical principles, and these are generalizations about the broad physical categories, and I consider these to be two very much intertwined things. You really can't have one without the other, or vice versa. And of course, one of these broad physical categories is the law of causality. But it seems, now that you're saying all of this, it seems like I need a whole different statement here, because I need a whole different statement here because I need a way to identify the way entities condition one another I need a law that captures the way entities condition each other's properties in these static ways. Like maybe it's the law of relationships or the law of conditioning connections or something like that. But I'm making, like, because I'm redefining causality to be kind of narrower, to specifically refer to change, I need a broader kind of statement. Although maybe what we can do is we can just say that Ayn Rand's law of causality, or I mean, really it's Aristotle's actually. She just brought it back since everyone forgot, apparently. Before her, everyone forgot about the right law of causality. I'm sure it's not as simple as that. I'm just being flippant. But Aristotle's law of causality can simply be broadened, or can simply be restated. It's basically Aristotle's law of causality. We just embrace it. We just cause it. We just change it to subsume all conditioning connections, which is really what Aristotle was going for anyway. So okay, but I can see. Yeah, you're not satisfied. So yeah, tell me where you're still not satisfied here.
But I don't want to discard what I think is a very valuable distinction you've made.
Yeah.
Between these kinds of causal forces that I would call it, or causal actions versus things like the various properties of a triangle that occur concurrently, and different perspectives on the whole. I think that distinction you make is valid and very valuable. So I'm not. I don't want you to. I shouldn't say I don't want. I mean, I would suggest.
Yeah, I can see you're not throwing the baby out with the bathwater. You're just trying to make the baby healthier.
Yeah.
Yeah. I can see that. But where do you think we can make the baby healthier, though?
Well, just by construing action to include force.
Yeah. I mean, but I really have, and yeah, you're specifically on this thing, again, it really does include force, though, because the creation or elimination of a force is an action. Then the fact of a force is a relationship. So force very much pertains to action still.
Yes, but I think the area that we're differing on here is I'm maintaining that because the forces still exist, even in an equilibrium state, right? Even when the net forces are zero, each individual force persists. And I'm arguing to consider that action, that there's still action going on through those exertion of forces.
And I would simply say that that's a number of relationships. Each of those relationships changes the net force property of the thing being of the entity under the forces. And that's it. Yeah, that's how I would say it. Why do you want it to be a force? Why do you want force to be an action? I guess I would ask.
Yeah, because it's a further constancy. So it's saying that the entity, any entity, is acting in a constant way, whether or not its force is offset, whether or not it's part of an equilibrium and there's no motion, it's still an attribute of this thing's characteristic action, that it's exerting its amount of force.
Right? Oh, okay, yeah.
It's just so the difference is I'm saying that the action persists. Like, so if the objects get into an equilibrium and they stay there for an hour, I'm saying that the action is persisting for that hour. I'm taking you to say the action happens when the equilibrium starts. Now there's no action, and then an action will come about again an hour later when I get tired and I drop that thing. I'm saying that the action. I'm saying that it's better for our understanding of the objects involved to construe all these things in a way I think is more constant. It's saying that this thing is constantly acting on the earth, and this object is constantly acting on this thing, and the earth is constantly acting on this thing. And if I pull this away, that's changed because this has moved away. But the earth, the characteristic way in which the earth is acting on this has not changed. It's always been pulling on this object.
I would simply say, why do you want to call this an action rather than a relationship?
Well, Because we have the law of causality, which tells us a lot about how things act, and we already have that law. Why use it only for when the things are moving and not use it these other times? Because it's the same kinds of properties that are in play. It's still a force each time, and why introduce a discontinuity in the way this thing acts? To me, it seems like a complication.
I would
And
simply say that we need to broaden the law of causality to include these static relationships. And once
that's
we
what I'm
include,
saying.
yeah,
Yeah.
and so the problem isn't that force is being conceptualized as a relationship. The problem is rather that now that I've narrowed what cause means, the law of causality now needs to maybe have a name change if this really ends up, if yeah, it needs to have a name change,
Well, yeah,
because you're
maybe.
absolutely right. The idea that entities act in accordance with their nature, that law needs to apply to the static cases too. But as a result, but as a result, we need to say that perhaps that entities relate to one another in accordance with their nature is maybe
Okay.
what we need to say instead. And that would end up covering action as well, since those relationships, once formed, action would be in accordance
Force.
with their
Yeah.
nature.
Okay, but let me ask a follow-up question, and this is from a layman, and you're the physicist. Is the fact that there is a force between objects, a force of some certain kind, like gravity or electrical, attraction and repulsion, the fact that there is such a force, is the fact that there is such a force a clue to thinking that there might be some kind of actual motion involved between these two objects, some intermediary
Yes.
object that are
Yes.
going. And in that case,
That's
uh,
already been proven physically, in my opinion. Like,
okay,
not philosophically, but like we have a physical reason for thinking or we have physical certainty. We have
okay,
certainty based on physical evidence, is what I'd say, not
okay.
philosophical argumentation. Yeah.
All right. Well, then all the more reason for construing force as a kind of action.
The way I think of it is this specifically. To gloss over a lot of physics, we know for a fact that some kind of emanation is coming out of the sun at the speed of light. And when that emanation strikes the earth, it causes it to be pulled in. And so the way I conceptualize this, and this is actually this is a broad physical principle. I call it, we don't need to go there. But incidentally, the immediate cash value of the broad physical categories and the broad physical principles is to make inferences about the nature of the ether, and gravitation is a phenomenon of an ether of some kind, and that's simply to say that actions are actions of an entity. There's got to be an entity between the Earth and Moon and all of these things. We know from there's philosophical arguments for an ether, which I'm not 100% convinced of, but the physical arguments make there's a freaking ether, because we know, just because of certain physical arguments. I haven't thought too much about the philosophical ones, since the physical ones make it way too obvious that there is an ether. So,
Mhm.
um, anyway, so okay, here's the way I think of it. There's two possibilities going on here. Either the sun is launching some kind of continuous stream of entities out of itself. Then what happens is that these entities, like, just to be funny, let's call them gravitons. The gravitons then hit the Earth, And when, or to be more precise, the gravitons come into physical contact with the Earth. That allows them to then act upon the Earth. And that action is the formation of some kind of relationship between the graviton and the Earth matter particles, which then change the net force property of the Earth particles, and then that net force property leads to its acceleration towards it. The other possibility is that gravity is not the emission of a constant stream of entities, but rather it is contiguous action through a media. So the Earth influences a part of the ether here, which then influences a part of the ether here, influence, and that, and then the ether, so what's going on is that these ether shells, if you will, each in turn are having one of their properties changed. Then once the ether next to the Earth is changed, that ether then acts upon the Earth in a way which is different than it would have acted before. Thus, the relationship between that ether and the Earth changes, and a new relationship exists, causing the Earth to accelerate differently than it did before. So that's how I conceptualize those things. And then I have a different way of thinking about. I have a broader argument again for why I want to conceptualize all actions, including forces, as changes in relationship. But let's see what you have to say about that ether explanation first.
Yeah, well, from my perspective, doesn't that argue that force is a kind of action?
I would simply say like that it involves action, that the force at any one time might change, and well, so to answer your question, let me actually get into the other thing I was going to say. This seems to be a kind of principle. And this is the first time I've formulated it, so I may have to try a couple times to get it right. Any change is a change of something. In the case of forces, there's definitely an aspect of force which is a change and an action. But what is the underlying thing that's changing? And Newtonian physics already gives us the answer that at any given moment, the net force of a body depends on all of the forces upon it at that moment. And so these forces at any given moment, I classify as a static relationship, which alters the net force property of the body. And then the action, the changing thing is a change in the force. And when we look at the different kinds of things which cause change in forces, we see what are the kinds of things which cause changes in forces? Contact versus non-contact. One distance between a gravitational body versus a different distance. These changes in other properties, here distance being a really key property, these changes of other properties are the causes of the changes in force. And so this seems to make it more conducive. This makes it more conducive to thinking of force as the static property, and then changes in force as being the dynamic action. Then, of course, force leads to changes because force causes acceleration, but that's a whole separate thing. That's later down the causal chain.
Okay, so all right, here's a question. Well, I can't say let's suppose since we don't know. So let me ask you the question. I am holding this white object up by this calendar. Is the Earth still sending its gravitons?
Yes.
So the action is still happening. The fact that there's a net force of 0 does not mean that the Earth has stopped sending its gravitons.
Mhm.
That is, the Earth is still acting on the thing, the force, the gravity. So it's different. The net force here might be 0, but it's not the same situation as if the Earth were exerting no gravitation and this thing were exerting no upward support, right? There's a difference. In one case, there's the gravitons, and in another case, there is repelling electrical forces, right, between this thing and that thing. And those things are netting to 0. But they're two different things, and they're both forces. They're both existing, and they're both examples of entities acting.
I would say they're both examples of entities in a relationship with the white box. And the two relationships each separately change the net force properties of the white box, and they happen to come out to 0.
Okay, so but isn't the Earth acting to send the gravitons?
Yes, it could be the case that the relationship between the Earth and the box, in fact, is constituted of a constant process of action. But if we're just thinking about Newtonian physics and that's all, then we would simply say that at any moment, the gravitational force upon the box depends on its distance from the Earth at any given moment. And so that distance necessitates a particular relationship. If that distance were to change, the relationship would change, and that change, I would say, is the action.
But doesn't it help to, having construed the actual exertion of gravity as an action, doesn't that help a scientist say, let me look for gravitons?
Yes, and the way I would say it is let's entertain the emission hypothesis instead of the action through a medium hypothesis. So then that relationship would consist of some kind of constant process of action, the constant absorption of gravitons. But until that's identified, we just see that at any point the force is the way that it is because of the relationship between the box and the Earth. And even once the graviton theory were confirmed, we could still talk about a state of unchanging graviton absorption as a kind of static relationship, even though that static relationship consists of a constant process of graviton absorption.
The process is an action, though, right?
That's what I'm saying. Yes. So it's like once you look deeper, you find out that the relationship is in fact this constant process of change, constant process of action. Like in this moment, it's getting hit by 2 gravitons, in the next moment, 1 graviton. and each graviton is separate. It's a separate particle that, each of these gravitons are separate particles. So like these would be, this would mean that the underlying nature of the relationship was a process of action, but we don't want to call it that until we find the actual changing thing. The actual, like, the action is the changing thing. The non-changing thing that still is a connection between the fact that the non-changing connection between the facts is a relationship. And so we say that like, again, these forces may indeed have action at their base, but so long as the force is a property of the entities that doesn't change, we need to call it a relationship because it doesn't change.
Isn't it both? Isn't there an action and a constant relationship? Can't we say both those things are happening? Things are always in a relationship, whether they're changing or not. Even when there's action, it's still a relationship. But calling it a relationship, I would think, does not mitigate it also being an action.
I deliberately separate those concepts, action and relationship, so as to capture the difference between a dynamic changing connection of facts and a static unchanging connection of facts. And so I would say that we don't want to merge these two things together so that we actually capture the difference between the two phenomena.
I guess I'd have to understand why that is a helpful thing, and I don't know enough of what you know to know that distinction is fruitful.
I think if I'm doing my job right, I should be able to convince you without specific physics, at least on this point. Some of the broad physical categories I introduce specifically because I think they'll help me with the ether. But this one is for this one, I think it's apparent from any from any human's perspective, or it can be argued from any human. It's not apparent, but like it's accessible to any human, and it's specifically this is that it's simply we want to capture the difference between entities playing a role in one another's identities in an unchanging way versus the way one entity might change another entity. When one entity changes another, that's action. But when the two entities have properties which depend upon one another, that's not action. We need a different word for that. And so that's, yeah, but you're not disagreeing with me on all that. You're disagreeing specifically on forces, right? This all comes down to specifically force, like literal, yeah.
But I'd also say we have that concept. That's what change is, and we have the concept static. What the only thing I'm saying is that's throwing me about your system is only the idea that action does not include a constellation of actions that might sum to a static sum.
Yes, I would like the gravitons or the atomic bond, and it does include that. Some relationships end up being constituted of these constant micro actions, these constantly changing micro actions that, because there's so many of them, they just kind of average out to this one constant thing. But if you look close enough at the constituent entities, you find out that those constituent entities are each, binding into a relationship and disbinding out of a relationship over and over again. And so that's an action, but that doesn't change the like, but you don't want to commit yourself to that being the underlying nature of the relationship before the specific constituents and their actions are identified. You just say it's a relationship.
Yeah, you can say there's a relationship, but all I'm saying is that maybe we're going in the circle now. I, again, I don't see how identifying a relationship precludes that there also being actions,
It
and I
does
think
not,
yeah.
because the relationships could end up redounding down to some kind of set of actions. But something I'll say, if we're doing a chicken egg, what is it called, what is that called, regress, if we're doing a chicken egg sort of regress, then whatever that action is the change of some relationship of some uh, even deeper entity. So in my view, what's really primary, I really, this is part of my view, is that what's really the primary is actually relationships. Because when change happens, something has got to be doing the changing. It's not the change that's primary, it's the unchanged, it's the thing with identity that changed into another identity. That's the primary. And in the case of connected entities, that unchanging thing, which sometimes changes when there's an action, that is a relationship. So relationships have primacy in my view. And so what and I'll stop there for now, actually.
Well,
Relationships have primacy in my view.
I'm just going to throw out an idea with that,
Okay. Yeah.
and that is that maybe this dance between action and relationship is similar to the relation between angle and side.
Uh
That maybe there's not one that has primacy over the other, but
mm.
rather they are concurrent and they are different ways of looking at the same thing.
I don't think so, because the action is, when we're talking about action, we're talking about change. So again, it change in what?
That's what you're saying, but I'm saying that the action also encompasses force, because there is stuff going on between the that's what I'm asking about, you know, and that all these things, is it all happening concurrently, that there is a certain relation of the objects, and at the same time each object has its way of exerting forces, and the way the forces are going to manifest is that it takes two to tango, right? And so they manifest ultimately based on how far apart the two things are, how they are in relation to each other. But the net motion or whatever is going to be based on the characteristic way this thing emits, those photons or those gravitons, and the distance and place where that other thing is. That all of that stuff goes into the mix. They're all aspects of the whole, and the way the the entities ultimately act, or stay the same.
Okay, I think I have a counter argument to this. Let me really quick. Okay. Um, um, that I think so. Again, if a relationship turns out to be some kind of constant process of action, such as, the sun emitting gravitons, and then the gravitons strike the matter of the earth, etc., then those actions of the gravitons, those changing properties of the gravitons, those changes would be the result of a changing relationship with the emitter and the absorber. So the sun does something to the sun is in a certain relationship with the graviton, then that relationship changes, and which makes the graviton start moving. Then the graviton comes into a relationship with the earth, which causes it to accelerate towards the sun. So these underlying actions would themselves have to be understood as changes in properties. These changes in properties being brought about by the changes in the relationships between the constituent entities, and those changes in relationships are what I call actions. I don't know if that helps. I'm kind of just saying the same thing over again.
Yeah, maybe we should put this as a table this for now.
Let's table this, because we're so yeah I so thank you for grilling me on this, and feel free to grill me more, because basically people either don't think this matters or they agree with me, and I suspect it's because, like, oh no, that's not true. There have been a few people who've disagreed in productive ways also, but it's rare. You're like the third person. The other two people were Lee Pearson and Bob Stubblefield, and Bob Stubblefield was giving you a hard time too with your book. If I
Bob disagreed with every new idea in my book.
But it sounds like it was in a helpful way.
Well, it was, Bob is a gentleman, so he's always going to voice his disagreements, gentlemanly way.
Well, you've definitely served that purpose for me, so thank you.
Okay, good.
Yeah.
And again,
and feel free to continue with that. I'm interested because I want this to be really battle tested. So right now my judgment is I'm not sure where you're coming from with your disagreement. That's where I'd be interested in digging more into where you're coming from. That's where I would want to go.
Yeah, maybe just like a closing thing is that I would be cautious about considering the law of causality having an area where it's not applying and then needing something else to cover those other things, some other rule. That's a big because
it's a big alteration.
Yeah, the alteration would be mitigated if you have some broader principle, right, that subsumes the law of causality. And
that's what I'm proposing, is that we would have a broader principle that would simply subsume the law of causality. And I may already have one, which I call the law of interrelation, which is that the identities of a set of interrelated entities condition one another.
But you'd also need a statement of the form that entities relate with one another in accordance with their nature.
It needs to be something more like that. Yeah. Entities in relationships condition one another in accordance with their identity. Maybe that.
And then the other thing I would just ask you to think about from your much deeper context is, does it help Does it help scientific inquiry to construe force as action?
Yeah, my current judgment is that it's clearer to think about it as relationship, as changing as change as a relationship fundamentally. And here's one particular place where it helps us. Doesn't help us with forces, but if we apply this conceptualization of relationship versus action across the board, it already yields fruit in the case of electromagnetic effects. So one electromagnetic effect is the Faraday effect, which is that a changing magnetic a changing magnetic field will cause a swirling electric field. Um, Only I actually said it wrong because that's not what's going on as far as we know. It's not that a changing magnetic field causes a swirling magnetic field. It's that a changing magnetic field necessitates a swirling magnetic field. Specifically, it may be this may be two perspectives on the same property of the ether because we are unaware of any temporal succession between the gust of magnetism and the swirling electric. They appear to happen at the same time. Maybe if we looked a little closer, we'd find that there was a temporal relation. I don't think so, though, because I've started looking at the deeper math of this, and they're really just the same thing. And so what this simultaneity, by conceptualizing the simultaneity of it, we say it allows us to see that they're really just two ways of saying the same thing. And relativistic electrodynamics basically already says this, just in a mathematically impenetrable way. It says it without talking about entities. It only says it in terms of math. But it basically, people already implicitly know this, that they're really just two aspects of the same entity, but they don't say the word entity because physicists don't think in terms of entities and properties and actions.
Okay, well, yeah. So that goes to your idea of like that sounds similar to sides and angles, right?
Yes.
Okay.
Yeah.
So there was something else that you said about the temporal thing. So um, maybe this has broader philosophical significance that you can't the saying you cannot reverse cause and effect, right? So cause has to precede, let's say, effect. If one comes later and one comes earlier, you can't reverse them, and that would go to your distinction, right? Because you can reverse sides and angles. It's two different respects. You can prove one from the other. They're concurrent attributes. Uh, Maybe the same is true with the magnetic field, electrical field. But one thing I don't know, I wonder, I mean, I don't know enough physics to know, is that does there actually have to be an interval in between? So for instance, if if this object, this billiard ball hits the other billiard, or this ball hits that one, and they react, I know this thing has to be going and it has to hit it first before the thing reacts. But is there an interval of time between the hit and uh,
The contact and the force.
between the contact and any motion, or is there a gap of time between the cause and the effect, or
Yeah, that's a good
the
question.
end? So, or is it just like
Yeah.
the end cause is concurrent with the beginning of the effect?
Yeah, that's a good question. So let me apply what I do know to this. So, like, if we just take Newtonian physics and that's it, then here's what we would say. We would say that the force can only happen once the contact happens. And there's clearly like a moment before contact and then a moment during contact. And as far as you can tell on the Newtonian level, the force happens during the contact. So it's concurrent with the contact.
And that's why with the bat, when the bat deforms and hitting the ball, it's going to be in contact with the ball longer, right? Because it's coming back and then it's going forward again. And so that's going to have more effect on the ball's velocity, right?
It's more complicated than that.
Okay.
Basically, like but it will have the different elasticities have different effects. Basically, yeah. But going to just this simple contact example, so the force, so the contact is part of the cause of the force. Is a necessary, or what do they call it? Yeah, it's a necessary cause of the force. Then and so the force is concurrent with the contact. Then the acceleration, the resulting acceleration of the struck object, that acceleration is concurrent with the force. That acceleration will, over the course of time, change the object's state of motion. So going with a ball, it's moving, the contact happens, the contact, the force, and the acceleration happen all concurrently.
Okay.
Then over the course of time, that acceleration causes the change in motion.
Okay, that answers my question.
Okay, yeah. So whatever the right way to think about this stuff is it needs to conceptualize these kinds of effects completely non-contradictorily. So I got some time to get this right. So I wanna get it. I really want criticism. I mean, even if I didn't have time to get it right, then like I'd want the criticism. But like it's especially it's not you know and it's especially important that I get it right because the rest of the things I'm trying to do depend on it.